Okay, so in this video we're going to have a look at logarithmic equations. Now the questions that you can see on the screen are the kind of questions that we're going to work towards. We're going to have a look at some beyond this as well. But in order to go about this video, you are going to need to make sure that you're quite comfortable with logarithms. So I would obviously ensure that you watch part 1 and part 2 on logarithms and just making sure that you understand the basics before moving on to this. And again, they'll be linked in the description. As we get further along, we're going to need to involve some algebraic fractions and obviously some solving of quadratics and stuff like that. So there are going to be some other topics involved, which again I'll link in the description. But with that being said, let's get started. Okay, so this is the first question that we're going to have a look at. So it says solve log base 2 of x plus 1, take away log base 2 of x equals log base 2 of 5. Now there's a couple of things that we can deal with here, and obviously something we'll take note of to start with, and that's that all the logs here have the same base, so we can apply all of those rules that we've looked at in the past. So for this one here, we've got two things we can deal with. We can deal with this left-hand side, because obviously we've got our subtraction rule here, and what we can do with those pieces after log base 2. And then we also have this piece at the end here, which actually does have a numerical value. And we'll deal with them both separately. So starting with the subtraction rule for the piece on the left. Now when we're taking away these logs, as long as they are single logarithms with the same base, we can divide those pieces at the end. So the x plus 1 divided by x. So we can write that out. We could write, okay, well that is equal to log base 2 of x plus 1 over x. We could put that in a bracket if we want, just to obviously define that that's all that piece at the end there. So that's what happens to that piece on the left, obviously just dividing those pieces at the end of the log, and that is equal to log base 2 of 5. So obviously thinking back to that first video that I've already mentioned, that means what power of 2 is going to equal 5. Okay, now actually that's going to be a decimal, so let's leave that as log base 2 of 5. Okay, it does have a numerical value, but actually it's going to be a little bit, maybe an easier way of us approaching this particular question. Okay, obviously that doesn't come out as a nice whole number, so actually let's leave it as it is. So what we've got there, that log base 2 of this algebraic fraction here is equal to log base 2 of 5. So that means if they are both equal and they are both log base 2, that this piece here on the left, this x plus 1 over x, must be equal to the 5, because log base 2 of each of them both have the same value. So what we can actually do is we can cancel out these log base 2's, okay? And we know that x plus 1 over x is going to be equal to 5. So let's write that out. X plus 1 over x is equal to 5. Of course, if log base 2 of 5 had a nice whole number, we could turn it into a whole number and then deal with the log base 2 from the other side. But as it turns out, it's quite nice and easy for us just to cancel both of them off there if they are both equal to each other. So now we have a, well, potentially a quadratic, but we've got an equation to solve. This one actually isn't going to form a quadratic. But let's have a look at how we go about solving this. Well, first of all, we need to remove this x on the bottom. So obviously we need to be quite happy with solving equations here. And in order to remove this divide by x, we're going to have to multiply both sides by x. And if we do that, we're going to get x plus 1 being equal to the other side times x, which is 5x. And there we go, there's our first step. Now we have a nice linear equation, and we can just subtract the smallest x from both sides. So take away the 1x from both sides, and we have positive 1 is equal to 4x. There we go. And then we want to know obviously the value of 1x, so we can divide both sides by 4, and we're going to get x is equal to 1/4. There we go. So obviously there is our solution, and that's our final answer, and that's obviously just our little starter question that's going to show us how to approach these solving logarithmic equations. Now from here on, we are going to have a look at some slightly harder equations that get involved, but there's our first question, and obviously do make sure that you are making some notes on these. So let's have a look at our next question now. Okay, so on to our next question. It says solve the equation 2 log base 5 of x, take away log base 5 of 3x equals 2. So slightly different, we don't have a log on the right hand side of the equation here, but we do have some other little bits to deal with. And again, just taking note, these logs do have the same base, so we can apply all of these little rules. But this log on the left is not a single logarithm. We have 2 log base 5 of x. So in order to do our subtraction rule here, we're going to have to use our little power rule, and we're going to have to move that 2 up to the x, or actually just our rearrangement of logs there, potentially bringing in our power rule later on. So in order to get that log on the left to become a single log, we can bring that 2 at the front up to the power with x. And again, thinking about that from some of our earlier videos, and do make sure you check those out first if any of these little bits with the logs are sort of going past you. So let's bring that 2 up. So that would become log base 5 of x squared rather than 2 log base 5 of x. Take away log base 5 of 3x, and that is equal to 2. Now they are both single logarithms with the same base. We can apply our subtraction rule like we did before. So we're going to divide those pieces. So we're going to have here log base 5 of x squared over the 3x. And again, you can put that in brackets if you want. Put that in a bracket, and that is equal to 2. Okay, so we're going to have to deal with this log now. As we only have the log on the one side, we can't just cancel it out from both sides. We're going to use our power rule here. I'm thinking about what this means, and it's a little bit more abstract than when we have just a numerical value here, but we have what power of 5 gives us the answer x squared over 3x. And it tells us here that that answer is 2. So in other words, 5 to the power of 2 is equal to this, x squared over 3x. What power of 5 gives us that? And it tells us the power is 2. So that's 5 squared. So in other words, if we write that out, in order to remove our log here, we can write that x squared over 3x is equal to 5 squared. And obviously we don't need to write 5 squared there, we can actually remove that and write the answer as 25. So let's just get rid of that. Obviously you leave that for your working, but let's just turn that into 25, as we know 5 squared is 25. Right, so from here we can actually form our equation now. Oh wow, we've actually already formed our equation, but we can get it into a singular line. So the first thing we need to do is we need to remove this 3x. At the moment it's being divided by 3x. So let's multiply that over to the other side. And once we do that, let's bring this up here, we get x squared is equal, not quite drawn the 2 in there, we go, is equal to 75x. And there we go. Now obviously we have a quadratic as we have an x squared in there, so we want to get everything on the same side so it equals 0. So let's minus 75x to the other side. So we get x squared minus 75x equals 0. There we go. And just like with any quadratic, we need to factorise it. This quadratic here has no number at the end, so in order to factorise that, we're going to want to put it into a single bracket. So let's take out a factor of x. So we get x brackets x minus 75, and that equals 0. There we go. So we get our 2 solutions here. We've got 2 possible solutions. We've got the x on the outside, which gives us x equals 0, and we've got the bracket there, which gives us x equals positive 75. Now we've got 2 solutions, and when we've got 2 solutions, we definitely need to check these out. Now when we're looking at a log, we can't have log base of 0. Okay, we can't have log base of 0, because that means what power of whatever the base is, in this case 5, what power of 5 gives you the answer 0. And there is no number that you can put to a power of 5 or a power of anything to get the answer 0, just like you can't get a negative number. You can get very small numbers, fractions, you can get very large numbers, but you can't get negatives and zeros. So 0, this one here, if we think about that in terms of substituting it back into either of our logs here, if we were to put it into this log on the right, we would have log base 5 of 3 lots of 0, which would be 0. And that's not possible. Okay, we can't have that. So 0 here is not going to be included. We can have 75 though. If we were to put 75 in there, we'd get some very large numbers. Okay, we get 225 for the one on the right and 75 squared on the one on the left. So 75 would be fine. It would give us a positive whole number. So x equals 75 in this case is our final answer for that question. And there we go. Let's have a look at our next one. Okay, and our last question here before you have a go, so do make sure you make some good notes on these. We've got to find the values of x such that 2 log base 4 of x, take away 2 log base 4 of x minus 3 is equal to 2. Okay, so we're going to take a very similar approach here, and you're probably seeing a little bit of similarity between these questions. And obviously we're doing this subtraction rule in the middle of all of them. Obviously just forming these little fractions is just a little bit more difficult than when we have a plus sign in the middle. So let's have a look. So obviously we've got this 2 at the start at the moment, and we need to deal with that to start with. So we need to get rid of that 2 and turn it into that power like we did on that last question. So let's do that to start with. So we have log base 4, and that's going to be of x squared. I'm just going to get rid of the bracket for the moment. And then we're going to take away log base 4 of x minus 3, and that is equal to 2. And again, obviously we're taking these away so we can divide them again and form that algebraic fraction. And if we do that, let's see what we get. We get log base 4 of x squared over x minus 3. And that is all equal to 2. And again, you can put this in a bracket if you want. So thinking about what this means again, this means what power of 4 gives us x squared over x minus 3, and it tells us here that that answer is 2, or 4 to the power of 2. So we can actually change that, and 4 to the power of 2 is 4 squared, which is equal to 16, so we can actually write this out as 16. So if we go ahead and write that out as 16, we will get x squared over x minus 3 is equal to 4 squared, which is 16. And there we go, we've got our equation. We've removed those logs now. And now we can just go about actually solving that. So first things first, we need to multiply this denominator over. And this time we've just got to be a little bit careful because obviously we have 2 pieces there. Okay, x minus 3, we've got a binomial to times over. So you can put that in a bracket if you want, and you could move it up next to the 16. But what I'm going to do is I'm just going to expand that straight out rather than creating some extra steps here. So we've obviously got x squared left on the left, and that's going to equal, and we multiply that bracket out, which we can do from down here. 16 lots of x will give us 16x, and then 16 lots of negative 3. Just obviously take your time doing that, but negative 3 times 16, not forgetting you do have calculators for this. You have 48 for that one, so it's negative 48. We'll take away 48. There we go. So obviously, as you can see, we've got a straight line quadratic again. We just need to make it all equal 0. So let's move everything to the left-hand side. So we have x squared, take away that positive 16x, and then add that positive 48. And that is all equal to 0. And now we can go about solving it. So if we solve this, let's have a think. Our factors of 48 can be 1 and 48. We could have 2 and 24. What else could we have? We could have 4 and 12. And actually potentially some more, but actually looking at this, we're trying to make negative 16 in the middle, and we can do that with 4 and 12, so we don't need to go any further. So if we factorise that, we'll have x minus 4, again we're trying to make minus 16 here, and x minus 12. And again, that's all equal to 0. There we go. Right, so solutions here, what do we have? We've got the x minus 4 in the bracket, and that's going to be x equals positive 4. And in the second bracket there, we've got x minus 12, so x is going to equal positive 12. There we go, so we get these 2 solutions. Now obviously not forgetting we do need to check them. It does actually give us a hint in this question. It says find the values. So values indicates that there are going to be 2 solutions. But for good practice on these, because you are going to have some that are going to come up throughout this video where some of these aren't going to work, like our previous one with the 0, you do need to make sure that you're checking these within your logarithms. So looking up at x squared, either of these numbers would give us a positive value if we square them, so that's absolutely fine. So let's check out this bracket here because we have x minus 3. So if we were to substitute 4 into that, we would get 4 minus 3, which is 1. Again, that's positive, so that's absolutely fine. And if we were to sub 12 in there, we would get 12 minus 3, which would be 9, and that's absolutely fine as well. But I think that's very important to note there that you do need to check those out, and you will have some hints sometimes in the question. If it did say find the value of x, that would indicate that obviously at the end you should only have one solution. But obviously just make sure that you check these on every question, no matter what the wordings, and it's just going to get you into that right habit of checking those final answers. So obviously that is the end of our first set of practice questions. Now, obviously there's a couple of topics involved here. You've got factorising and solving quadratics, and obviously just rearranging some of the equations and stuff like that, obviously just making sure that you can get it into that quadratic form. So again, I'll link all those topics in the description if any of these have thrown you a little bit, but here's a couple of questions for you to have a go at. Okay, so here are two questions to practice. We've got two different types of questions here. We've got the one on the left where it says find the values of x, so you are going to get two values for that one. And for the one on the right, it says given that x is between 0 and 2, find the value of x for this particular logarithm on the right here. So obviously on that one there, it's just giving you a defined sort of range of values that you're allowed, so it's only allowed to be between 0 and 2, so it's going to be quite a nice easy one. But again, you can test that out in the logarithm just to make sure they're both okay, but that gives you a little bit of a hint for your solution there. So pause the video, have a go at both of these, and we'll go over the answer in a sec. Okay, so for the first one, so we need to bring that 2 up to the power. So if we do that to start with, we get log base 3 of x squared, take away the log base 3 of x minus 2, and that is equal to 2. Now we can do our subtraction rule, so we'll have log base 3 of x squared over x minus 2, and that is equal to 2. So that means what power of 3 gives us this algebraic fraction? The answer is 2, so it's 3 to the power of 2. So making our equation here, look, we've got x squared divided by x minus 2 is equal to 3 squared, which is 9. Now we can multiply the x minus 2 over, and again you can put that in a bracket if it helps you to multiply it over, but when we do that we get x squared is equal to, and timesing both of those by 9, we get 9x minus 18. And then if we move that all to the left hand side, we get x squared minus 9x and then plus the 18, and that equals 0. Now we need to factorise it to get our two solutions. So having to think about 18, that also makes 9. 3 and 6 is going to work for us. So we get x minus 3 and x minus 6 equaling 0, which gives us two solutions there. We get x equals positive 3 and x equals 6. And again, just thinking about these two values within our logarithm, obviously our first one there is just an x, and both of those are going to be fine, they're both positive. And for this one here we have x minus 2, 3 minus 2 is 1, and 6 minus 2 is 4, so both of those are absolutely fine. And again, it did give us the hint there to find the values, so we knew they were going to be 2 anyway. But there we go, there's our first one. Let's have a look at our second one. So for this one here then, we have log base 3 of 2 minus x, take away 2 log base 3 of x equals 1, find the value of x. Okay, well let's deal with this 2 at the start. So we have log base 3 of 2 minus x, and then let's take away, and we have log base 3 of x squared, and that all equals 1. Now again we can do our subtraction rule, it's just we're going to get our x squared on the bottom this time. So we have log base 3, and we're going to have 2 minus x over x squared, and that equals 1. Now obviously we can get this log base 3 out of the way, so that means what power of 3 gives us that, and it's 3 to the power of 1, so 3 to the power of 1 is 3. So if we actually write this out, we have 2 minus x all over x squared equals 3 to the power of 1, which equals 3. Now we can multiply that x squared over, so we have 2 minus x equals, and if we times x squared over to the 3, we get 3x squared. And then for the purpose of this one, it's probably easier for us to move everything to the right rather than having a negative quadratic. So if we move everything to the right, we're going to get 0 equals 3x squared. We're adding x over, so plus x, and we're subtracting the 2 over, so minus 2. And there's our quadratic that we need to factorise. So let's factorise that. So in one of our brackets, we're going to have 3x this time. So obviously we've got some factorising of harder quadratics here, and our factors can only be 1 and 2, and we need to make 1 in the middle. So if we have 3 times 1 is 3, and the 2 over here, that's going to make 3 take away 2, which we can have as 1 there. So we're going to want that as positive 3, take away the 2, and that is going to give us our solutions. So the first bracket there, we're going to have x is equal to, and we have positive 2 over the 3. And for this one here, we have x equals negative 1. And there are our two solutions there. But obviously thinking back to the question, it says given that x is between 0 and 2. Obviously negative 1 there is not between 0 and 2. So we can't have negative 1. Okay, but 2/3 is between 0 and 2, so we can have 2/3. So x equals 2/3 is our value of x that works in this logarithm. But again, thinking about testing, obviously you could put that -1 into the obviously either of those logarithms there. I mean, 2 take away -1 would be fine, that would give you 3. But obviously x being just a single x in the first one, you couldn't have -1 in there, but it is x squared, and -1 squared is +1. So it would actually give us a positive value there, but that's why it's defined it for us and saying given that x is between 0 and 2. So obviously -1 doesn't fit within that range. So x equals 2/3 is our answer, and there are those questions. Now let's have a look at one more style, or just something a little bit, tiny bit harder, just to finish this off. Okay, so you've had a good little practice on some of these. Now I'd encourage you just to sort of pause the video and have a go at these and see what you get and see if you can figure them out. But we're just going to have a look at a couple of questions with one for you to finish off on. And I'm going to go through these relatively quickly, so I would encourage you to have a go, as I said, and let's just see what we get. So this one here says find the exact value of x such that log base 2 of 2x equals log base 2 of 5x plus 4 take away 3. Now in order to actually go about using our subtraction rule here, we need to actually subtract this piece here over to the other side so that we can combine these logs. And not forgetting that's going to leave us with -3 on the right there. Now, obviously not forgetting the symbol just in front of it. So if we move that piece over to the left, we would have log base 2 of 2x take away log base 2 of 5x plus 4, and that is now equal to -3. So you're already seeing one of the slightly harder steps that can arise where we just have to rearrange it first. But now we can apply our subtraction rule like we did before. So we have log base 2, and we'll have 2x over 5x plus 4, and that is equal to -3. And now's our next step where some slightly more difficult elements can come in. So we have obviously -3 over there as our answer, and that means what power of 2 gives us this element here, and that power is -3. So that's 2 to the power of -3. And let's work that out just to the side here, 2 to the power of -3. Obviously you can type that into your calculator, but I'd hope you know your rules of indices here. When we have a negative power, it's going to flip it over, so it becomes 1 over 2, and we've got a power of 3 there, so they're going to be cubed. So 1 cubed is 1, and 2 cubed is 8. There we go, so it's 1 over 8. So removing the log will give us 2x over 5x plus 4 is equal to 1/8. There we go, just obviously some negative indices being involved here. And now actually we have a fraction on both sides. We can cross multiply this, so we can multiply the 5x plus 4 up to the 1, which is easy enough, and the 8 over to the 2x. So if we multiply the 8 over to the 2x, we're going to get 16x. And multiplying the 5x plus 4 up to the 1 just gives us 5x plus 4, so that one's actually quite nice there. And as you can see, this one here doesn't even form a quadratic. So this is okay. It says find the exact value though, so we'll have a look and see what we get. So take away the 5x from both sides, that would leave us with 11x, and that is equal to 4. And then we can just divide by 11. So we have x is equal to 4 over 11, and that is our exact answer there, just leaving that as a fraction. So there we go, there's our final answer. Just some different elements within that. Obviously we had the negative power that gave us 1/8 on the other side, and we also had that element at the start just moving a piece over first. So you can start to see how some of these can look a little bit more complicated, but actually following the same process of what we've already looked at. Right, okay, let's have a look at one more then before you finish off on your final question. Okay, so this one here, find the values of x such that 2 log base 2 of x plus 15 take away log base 2 of x is equal to 6. And again, nothing too crazy in this one, let's just have a look at working it out. Now the difficulty here is that when we bring this 2 up to the x plus 15, that's going to form a double bracket there, it's going to be a squared bracket. That's okay, we'll work that out as we go. So we have log base 2, and that's going to now be x plus 15 squared. And then we're going to take away log base 2 of x, and that is equal to 6. Obviously we just need to deal with that double bracket there, so we can expand that out and see what we get to start with, or we could just leave it in a squared bracket and potentially deal with it later. I don't think it really matters which way you do this here, it's completely up to you. We can always convert it back to the, obviously back to the bracket if we want to at a later step, but let's just go about working this one out. So obviously applying our subtraction rule, we will have x plus 15 on the top, or the x plus 15 squared, but we're going to have log base 2 x plus 15 squared over the x, and that is equal to 6. Let's deal with the log base 2 to start with. That means what power of 2 gives us this answer, and it gives us the power there, which is 6. So we need to do 6 as our power of 2. So we have x plus 15 in brackets squared all over x is equal to 2 to the power of 6. And obviously we can work out 2 to the power of 6. It's not the hardest to work out. 2 times itself 6 times, but the answer there is 64. So let's multiply that over, or that x over, but let's actually write 64 there instead of 2 to the power of 6. There we go. So multiplying the x over, and we're going to need to expand that double bracket as it turns out. So let's actually go about doing that. So we have our bracket to expand, not forgetting there's 2 of them. So we have x plus 15 times another x plus 15, and that's going to give us x squared plus 15x twice, so plus 30x, and then plus 15 times the 15, which is 225, so plus 225. And that is going to be equal to, when we times the x over, 64x. There we go. So I've done 2 steps there. I've expanded the double bracket on the top, and I've multiplied the x over to the other side. Let's just put a little symbol in there just to show that we've done that as well. Now let's make this equal 0. So we have x squared plus 30x, and then we have 200. Oh, actually, no. If we're going to do this, let's actually move the 64 over. There we go. So take away that 64 would give us minus 34x. There we go. So 30 take away 64 is minus 34x, and then plus the 225 that equals 0. There we go. Now, not the nicest one here. Obviously, if you know how to do these on your calculator or solve them nice and easily, you can always type this into your calculator to do it, but I'm going to just keep following the factorisation method. I think as long as they're okay to do, we may as well just use that method as we've used it so much. So for 225, we obviously have 15 and 15. That's not going to work for this one. What else do we have? We've got 25 that goes into it. 25 goes in 9 times, so 25 and 9. And actually, there we go, we're going to be able to make 34 out of those. As you can see, not too difficult there, even though we've got quite a large number at the end. So actually, if we factorise this, we're going to have x minus 25 and x minus 9 that equals 0. And there we go, that's going to give us our 2 solutions. We're going to get x equals 25 and x equals 9 for that second one. And there we go, there are our values of x that work in that logarithm equation, or that logarithmic equation. So there we go, obviously just showing you another element there that can be quite difficult. If you've got to expand some double brackets, you've got to form quite a nasty quadratic and solve it from there. But just a couple of examples there to show you some of the differences or some of the harder elements that can come up within these as well. So let's have a look at our final question for you to have a go at and just see how you get on with it. Okay, so this is our final question, so pause the video there, have a go at this one, see what you get, and we'll go over the answer in a sec. Okay, so first things first, we need to move this log over here to the left hand side. And if we move that over, we're going to get log base 3 of x plus 1, take away the 2 log base 3 of x minus 1, and that is equal to 1. There we go, so we've got that first element that we looked at in the first question. We have to move the piece over first, and now we have to deal with this 2 here. Okay, and that's going to give us a squared bracket, just like in our second question. So if we do that, and let's actually do our subtraction rule at the same time, we could do log base 3. We've got the x plus 1 on the top, and on the bottom we're going to have, and not forgetting what we're doing in this step here, we're just bringing the 2 up to the power. So on the bottom we are going to get x minus 1 in brackets squared, and that is equal to 1. Okay, so we have log base 3 of x plus 1 over x minus 1 squared equals 1. Now, not forgetting what this means, it obviously means what power of 3 gives us this element here, and that power is 1, so it's 3 to the power of 1. So if we actually get rid of the logs here, we have x plus 1 over the x minus 1 squared is equal to 3 to the power of 1, which is just 3. There we go. Now we can actually go about expanding this bracket on the bottom, and then we can multiply it over to the 3. We could multiply it over first, but I think it's just a little bit easier here if we just expand it and then move it over. Completely up to you though. So let's actually go about doing that. So let's bring this up. So we have x plus 1. And if we expand that double bracket there, and obviously you can write that out and do all your working, but you get x squared minus 2 lots of negative 1x, so negative 2x, and then plus 1, and that is equal to 3. Now we can actually multiply this bottom bit over. Just remember, we're just going to multiply that over, times them all by 3, which as we've got a 3 on the right hand side there. So we have x plus 1 is going to equal 3 lots of all of these, so 3x squared minus 6x plus 3. There we go. Now we need to make it all equal 0, so let's minus the x and minus the 1 over, and that's going to give us 0 equals, and we get 3x squared minus 7x minus the 1 would give us plus 2. That's quite nice, just having a 2 at the end. That's going to be nice and easy to factorise. So let's factorise that. We get 3x and x. It can only be 1 and 2. So how are we going to make 7? Well, we want to triple the 2, as we have a 3x there. So that's going to equal 6, and then our 1 can go over here. We're trying to make negative 7 in the middle, so they're both going to be negative. And there we go. There is our quadratic factorised, and now we can actually get our two solutions from there. So for the 3x minus 1, and let's think about where we can actually write this. Let's write it up here. We're going to get x equals a third. And for the x minus 2, we're going to get x equals 2. And there we go, there's our two solutions. Now, obviously, it did give you a hint in the question there, find the values of x, but again, you could test these out. You've got 1 plus a third, and obviously the starting one there, and then our second one, obviously, it's going to be x minus 1 squared. So obviously, 1/3, take away 1 is negative, but then when you square that, it becomes positive, so that is going to work within that log as well. But there we go, there's our two solutions. And there is the end of that video. So I hope you found that useful and helpful. On the next video, we are going to have a look at going over a few of these questions, some slightly more difficult ones, but we're not going to go too much further than this. Okay, these are quite tricky questions in their own right, but we are going to do one more video just having a look at some difficult versions of these. As you can imagine, when you obviously go over some of these practice papers and stuff, you always end up with a difficult version of the question. But that's it for this video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.